horizontal velocity of the ball. So we want to find Vx, right? We have one equation for that. So we got delta dx equals Vx delta t. So we want Vx. So we know that it went 56.6 meters horizontally. And it did that in the time we determined, 3.3 seconds. So when we do that, we get initial x velocity of 17.2 meters per second. So that's our x velocity. Now number 4, we want to do, get the VIY. Now if we think about it, right, when he releases the ball, let's say he releases it right around here. Okay, so he's right around chest height, and then it's going to travel, and we're going to say that it was also caught at the same height. Now that assumption is important, and I'll explain why afterwards. But the maximum height, which would be right here, is not 3.3, right? 3.3 is to here. The maximum height is half of that time. So to get here was 1.65 seconds, right? And that is the maximum height. That is also where the Vy is 0. So we can use that information to get our VIY. So use the first equation. And now Vy is 0, so we'll make it 0 there, equals VIY plus G, and then the time at that point is 1/2, so 1.65 seconds. So now you calculate VIY, so you got 9.8, 165, 16.2 meters per second. So the Vx is 17.2. Write these here, and the VIY is 16.2 meters per second. Now, this works because he's throwing it and catching it at the same height. Let's say that Tom Brady was up here when he threw it, for whatever reason.
There's a box in the field.
There's a box on the field, right? Now, when the ball does its parabola and gets to the receiver, the max height, right, that's not equal to half the time anymore, right? This is not half the time, right, because half the time would be, if we were catching it there, then that would be half, but we're not, so it has to do this, and then it has to fall this extra. So you can't use that Vy is 0 at half the time here, because it's not thrown and caught from the same height. Does that make sense? That only works when they're from the same elevation. So that's why we made that assumption in the problem. Now, number 5, we want to find the maximum height. So that's going to be, we go back to our original picture. That is now half the time, the overall time, and also we know Vy there is 0. So we could use either one of these facts to get the delta dy at this point. We could either use the third equation or this equation with half the time, now that we have our VIY. So I'll use the third equation. And I'll make this 0, and then we'll use the VIY we got. Solve for delta dy. So your max height is about 13.4 meters. So that's our max height. Now we don't actually need that information for number 6, but it was just something we could calculate. And then number 6, we need to get the initial velocity of the ball. So when Brady released it, say right here, it went off this way, right? And what we know is that the x component was 17.2 and the y component was 16.2. So now you do your Pythagorean theorem on those. And you got 23.6. So the overall velocity is 23.6 meters per second. And then you got to get an angle. Find that angle using inverse tangent. .3 degrees. 43.3 degrees. So the velocity was 23.6 meters per second, 43.3 degrees.